Welcome back. I'm Muggsy, and today I'm going to explain chemical formulas. Before we talk about chemical formulas, it's important you know a thing or two about atoms. I've got a video on that. And then also on atomic symbols. I have a video on that as well. Okay, so let's take a look at this chemical formula here, CH4. This is actually a really useful way and the most common way that chemists write down the identity of a compound or any substance, really. And that's because this substance, CH4, might be known as carbon tetrahydride, 1 carbon, 4 hydrogens, or you might call it methane, or maybe in some places in the world you might call it methane. And so there's lots of different names for any given compound. But instead of using all these different names, we can just use one chemical formula. So even though it has multiple names, it only has one formula. CH4 is always CH4. So that's a really good reason to use chemical formulas. The other idea is that with all of our calculations and stuff, it's much shorter to write CH4 than to write out methane or carbon tetrahydride, which is even longer. And then finally, this tells you so much about this compound. It tells us that it's made of 1 carbon and 4 hydrogens. So let's talk about how I just did that, how to read a chemical formula like you see here. Well, the different elements in the chemical formula are written out as their atomic symbols. So the big C is for carbon and the capital H is for hydrogen. And then we use subscripts following the appropriate element to tell us how many atoms there are. So because there's a little 4 after this hydrogen, it's telling us there are 4 hydrogens. And because there's nothing after this carbon, it's telling us that it's made of 1 carbon. So this is a chemical compound made of 1 carbon and 4 hydrogens. It's 2 elements, carbon and hydrogen, and a total of 5 atoms, 1 carbon atom and 4 hydrogen atoms. Let's look at another example to really kind of get this down. What if I told you, what if I gave you this chemical formula, Cl2? Well, how many elements do you see here? Just 1, right? This is chlorine. The C is capital and then the L is lowercase, as is the case for many atomic symbols. Okay, how many atoms do you see here? If you said 2, that's correct, because there's a little 2 after the Cl, telling us that this is 1 chlorine bonded to another chlorine, which might seem kind of silly, like why would that happen? But in reality, that's really common around us in the natural world. A lot of things, as you'll learn later in your chemistry course, a lot of elements are unstable on their own, and so they needed to be bonded to something else to be stable, and in many cases that's just themselves. So 2 chlorine atoms bonded together become a stable chlorine molecule. Okay, so a chemical formula, it might be just a single element like you see here, or it might be made of several different elements like you see here for our methane. What if I asked you to write down the chemical formula of pure argon gas that's not bonded to anything, even itself? The chemical formula would just be this. It would be exactly the same as the atomic symbol because all a chemical formula is a bunch of atomic symbols stuck together, and if it's not bonded to anything, then the chemical formula is exactly the same as just the atomic symbol. This represents a single argon atom all by itself, not bonded to anything, not even itself, like with this chlorine here. Here's another example. What about this chemical compound? You're probably familiar with this. This is water. And the chemical formula here is just telling us what exactly water is. It's 1 oxygen and 2 hydrogens bonded together. 2 elements, hydrogen and oxygen, and a total of 3 atoms, 2 hydrogens and 1 oxygen atom. How many compounds do you see here? Well, just 1 compound or 1 molecule. Yeah, all of that information is contained in these different chemical formulae. Let's look at some harder examples now. What you see here is potassium phosphate. You don't need to know how to name them yet. That'll come much later. But you should be able to look at this now and see that this is a compound made of 3 different elements: potassium, phosphorus, and oxygen. You should also be able by now to tell me exactly how many atoms there are of these different elements. You should be able to tell me that there are 3 potassium atoms, 1 phosphorus atom, because there's no number here, it must be 1, and 4 oxygen atoms, for a total of 3 plus 1 plus 4, 8 atoms. 3 elements, but 8 atoms. Okay, now sometimes you'll see a coefficient in front of your chemical formula, like let's say there was a 3 in front here. And notice that this 3 is written as a full-size number. It's not a little subscript like these other 2 are. So coefficients in the front will be a full-size number. And what this is telling us is that instead of just having 1 potassium phosphate molecule, we have 3 of them. So 3 basically of this whole thing. So now, if I asked you these same questions, how many elements and how many atoms do you see? Let's answer that. So how many elements do we see here? Well, it's still the same. It's still just potassium, phosphorus, and oxygen. So now we have a total of 3 elements, just like we did before. Nothing has changed. How many atoms? Well, now things get a little bit trickier. Let's count them all individually. So if we have 3 overall potassium phosphate molecules, that means we have 3 times 3, 9 potassium atoms, because each molecule has 3, and we have 3 total molecules. So 3 times 3 is 9. Each molecule only has 1 phosphorus. So if we have 3 molecules with 1 phosphorus apiece, we only have 3 phosphorus atoms. And then if we have 4 oxygens per molecule, and there are 3 of them, that's 3 times 4, a total of 12 oxygens. If we just add these up, we basically get 24. 24 different atoms. And you'll know that the difference between these two is this is just 3 times more. So a number in front of your chemical formula will tell you how many of the whatever that is that you have. So this 3 tells us we have 3 K3PO4s. If we had a 2 in front of an H2O, it would say we have 2 water molecules. If we have a 5 in front of an AR, that would tell us we have 5 argon atoms. This coefficient in front tells you how many of the thing there are. Okay, let's do a more complicated example now. Here's a more complicated example. What you see is calcium hydroxide. A calcium, some oxygens and some hydrogens, and a parentheses here to kind of make things a little bit trickier. But it's really not complicated. Parentheses with chemical formulas basically behave like parentheses in math class. And so what this is saying is that we have 1 calcium, and then we have an OH with a 2 outside. So that means 2 OHs. So you could think of this almost as 2 O's and 2 H's. Because just like in math class, if we have a 2 outside the parentheses, we have to distribute it to both things inside the parentheses. So since we have an O there and an H there, that basically means there's 2 oxygens, 2 hydrogens, and 1 calcium. Now, you might be thinking, and correctly so, like why don't we just write it out like this? Calcium O2 H2. There's a couple reasons. For one, this is maybe a little bit just more to write than that, especially as we get more and more things in the parentheses. But the bigger and more important reason is this is actually telling us something structurally about this molecule. We don't know this yet, we haven't learned this yet, but you will later on in your chemistry course. And that is this OH is stuck together. It's a polyatomic ion. And so what this actually looks like, if you looked at it, would be a calcium ion with 2 OH ions bonded to it, kind of like this. And so this is a good example of the chemical formula telling us a little bit of what the structure of the molecule actually looks like. As with before, If there's a coefficient on the front of the molecule, that's actually going to complicate things a little bit. So let's say there's a 4 in front here. Instead of having just one calcium hydroxide, we have 4 calcium hydroxides. Okay, that means basically you could draw a parentheses around this whole thing. That might make it a little bit easier for you to think of 4 calcium hydroxides. And again, this 4 has to get distributed to everything, just like that 2 has to get distributed to everything. So the 2 gets distributed to the H and to the O, and then the 4 gets distributed to all 3. Okay, that looks complicated, but let's just count it and do the math. It'll be much simpler. So 4 calciums. That's easy. So we have 4 calciums. How many oxygens do we have? Well, each calcium hydroxide has 2 oxygens. So if we have 4 calcium hydroxides and each one has 2, that's just 4 times 2, 8. 8 oxygens. Same thing with our hydrogens. Each calcium hydroxide has 2 hydrogens. And if we have 4 of them, then 4 times 2 leave 8 hydrogens. So if we have 4 calcium hydroxides, we have 4 calciums, 8 oxygens, 8 hydrogens, 3 elements for a total of 20 different atoms. How many molecules do you see here? Well, 4. There's 4 calcium hydroxides. Okay, let's do one more example that'll challenge you a little bit even more, and then I think you'll know everything you need to know about reading chemical formulas. Okay. Here's an even more complicated example. We're looking at ammonium phosphate. Specifically, we're looking at 2 ammonium phosphates. So we're talking about one compound, ammonium phosphate, with 2 total molecules of that compound. And then let's just kind of go through and count all the individual atoms that we see here. So for instance, if we wanted to know how many nitrogens there are, here's where things get a little bit tricky. And it might be helpful to separate this out with a big parentheses there. We have a 3 subscript outside the parentheses here. And as I taught you earlier, subscripts outside of parentheses need to get distributed to both things inside the parentheses. So that means there are, since there's no subscript after this nitrogen, it must just be a 1. 1 times 3 is 3. There are 3 nitrogens in every 1 ammonium phosphate. Now, there's a 2 coefficient in front, so we're talking about 2 total ammonium phosphates. So if there's 3 in each one and there's 2 of them, that means we have a total of 6 nitrogen atoms. Hydrogen atoms. Well, there's 4 hydrogen atoms in the parentheses here. This is an ammonium. You don't need to know that. And there's a 3 outside the parentheses. So there's 3 of these things, 3 NH4s. So if one NH4 has 4 H's, 3 NH4s has 4 times 3, 12 H's. But we're not quite done, right? Because we have this subscript in front. So if each one of these, each ammonium phosphate has 12 hydrogens, and there's 2 of them, we're actually talking about 24 hydrogens. I almost forgot that coefficient in front. Okay, next, here you'll see 1 phosphorus. Now, you might say there's a 4 here. Do I need to multiply that P by 4? No, because the phosphorus isn't inside of parentheses, so it's just 1 all by itself. So there's 1 phosphorus in every ammonium phosphate. There's 2 total ammonium phosphates, 2 times 1, 2 phosphoruses. Oxygen, you see 4 of them here. There's 2 of this whole thing, so that's a total of 8 oxygens. Okay, let's just do some quick terminology. If I asked you how many elements there are in this ammonium phosphate, you would say 1, 2, 3, 4. Nitrogen, hydrogen, phosphorus, and oxygen. If I asked you how many hydrogen atoms there were, you could do the calculation and tell me there's 24 hydrogens. And then if I asked how many total atoms there are in 2 ammonium phosphates, you could add these all up. 6 plus 24 is 30, 2 plus 8 is 10, 30 plus 10 is 40, you'd say 40 atoms. So, chemical formulas, You'll learn to love them because they're quick, they show a lot of information in there, and they're really easy to write and understand, especially once you understand what's going on with the parentheses. Always account for the parentheses when you're doing your math in chemistry, exactly as you would in your math class. And if you want to practice reading chemical formulas, go to learnsomething.app. We'll give you all the practice you need to be an expert at this skill. So for instance, if I were to ask you how many oxygen atoms are in the molecule shown, you should be able to tell me 2. And once that bar fills all the way up, you'll have demonstrated total proficiency of this skill. A number of elements here. Okay, it's 3 elements, but let's say I get that wrong. Boom. We'll be able to show you exactly how to calculate the right answer for that particular problem. So yeah, head on over to learnsomething.app. Have fun practicing this skill, and I'll see you next time.